Hey, Algebra 2 honor students, this is going to be Unit 18, Day 5. Today we are talking about the difference between populations and samples, and then some characteristics that would describe each of those two criteria there. So you can see at the start of the notes here on page 28, we are looking at just writing some definitions for each of these things. So if you want to get started here, let's talk about populations first, and then population characteristics. So population is an entire group that we're interested in learning something about. And some characteristics that we can use to describe that population are the mean and or the standard deviation for the population. Now, these are symbols that we're pretty familiar with. These Greek letters, mu and sigma, represent the mean and the standard deviation respectively there for the entire population. So in terms of symbolic representations here, where we're talking about means and standard deviations, we'll try and be careful about which symbols we use, because we'll use some slightly different symbols when we're talking about mean and standard deviation for a sample. So the entire group that we're interested in is considered to be our population. So meanwhile, when I move this down to think about what a sample is a subset of the population. So that kind of makes sense. In our examples, what we're looking for is we want a representative sample. If we want to make some conclusions about a certain group of people, and we have a sample that we're choosing from, we want that to be representative of the entire group that we're looking at, that entire population, okay? So we see this in observational studies and experiments, that we might take a subset of the population and make some conclusions based on some observed data. So the mean or standard deviation of a sample, notice how the notation changes a little bit, where we have x bar representing the mean and s of x representing the standard deviation. If you look back at the homework 1 for this unit, you will see both of those notations used. When you type data into list 1 in your calculator and run one variable stats, you'll see that these are the pieces of info that you're given because we're looking at a specific sample. Okay, so x bar is the average and then s of x is the standard deviation. So once you have all that down, what you'll see is that we have some examples below, and it says for each of the following, decide if the group described constitutes a population or a sample, or could it be considered to be either a population or a sample? It's probably a stronger case for one as opposed to the other, but certainly read through each of these examples. See if you can decide if you think it's a sample or a population. In terms of the explanation, you don't have to write a formal explanation, but just maybe in your head, think about if we were in class right now, being able to justify why you think it's one as opposed to the other. So I'm going to go through these answers. So if you want to hit pause and give it a try. Let's take a look at, first of all of the animals that live in Yellowstone National Park. When you see that clarifying word, all of the animals, that's typically an entire population. So I would consider part A to be a population. Could we also say it's a sample? You know, maybe if we're looking at a sample of all the animals that live in all of the national parks, yeah, I mean, just Yellowstone would be a sample in terms of that larger population. So you can probably make a case for multiple in this case. That's why that explanation might come into play. But if we're talking about all the animals in Yellowstone National Park, that's probably a population most likely that we're trying to describe. If we're looking at 20 randomly selected juniors from FHS, I would say that this is a sample. Okay, so when we randomly select, and that random selection is important in terms of trying to get what's called that representative sample. Okay, the more randomly we pick people, the better off we'll get a case where we get a representative sample of the population. Okay, so that would be sample for that one. All the student athletes on the swim team were asked their political viewpoint. You know, in this case, because it's all of these athletes, I know it's just the swim team, so could you justify sample here? I think so. But because we got all of the athletes on a particular team, I would say we could also classify that as being a population. Okay, this qualifying word of some cars on the lot at a local car dealer, just some of them would definitely be a sample. If we're looking at the words of the Gettysburg Address, we're not looking at just specific words. We're looking at all of the words. So since we're looking at the words, I would say that this one's a population. And then last but not least, if we have 4 colors we select for a painting from your art teacher selection of 196 colors, well, I'm only picking 4 of them. So that I think is a pretty clear case for a sample in this case. So hopefully you got most of those correct. If there's a few that you want to chat about with me next time we're in class, of course we can do that. But hopefully I gave you a good reason to think about, yeah, some of these that I said sample could, I think, also be considered population. and vice versa. Some that we set population for, depending on what we're looking at in the broad, the grand scheme of things, could also be considered just to be samples. All right, in continuing our discussion of samples and populations, on the next page, what you'll see is some examples where you're given some statistics. And what we want to determine on this page is, are these population characteristics or sample statistics? So is the information that we're given, this numerical information, is it a population characteristic or is it just a statistic for our sample? So let's say we talk about the population of interest is the junior class at Fairport High School. Okay, so that's the population we're looking at. Are each of these characteristics of the population, or are they just sample statistics? Well, for part A, the proportion of juniors at Fairport High School with red hair. Since our population of interest is the junior class, I would call this a population characteristic. So a population characteristic. Okay, if we have that sample proportion of 18% or 0.18, that proportion, well, that's for the entire population of juniors, and that's our population of interest. All right, here in part B, the average number of siblings of the juniors in AP Humanities is 16.3. Well, we're now reducing the junior class to just students who take AP Humanities. So since we're shrinking the fields here, this would just be a sample. Okay. All right, let's keep going on to the next example. In a random sample of 25 juniors at FHS, 2 of the 25 of them are red hair students. So this one is pretty clear. I would say that this is going to have to be a sample statistic because we're taking a random sample of 25 of our juniors. So this is definitely sample again. And if at any point you want to try these last two, of course, you can hit pause and go for it. This one says the proportion of students that are only children in the junior class at FHS. Well, we're looking at the entire population. So this would be a population characteristic. And finally, of the juniors on the track team, 35% of them take at least one AP class. This now we're reducing it to a sample. We're only looking at juniors on the track team and looking at a statistic that's specific to those students. So again, breaking down a little bit more with population versus sample, these mathematical quantities associated with these two, hopefully we can think of it as a population characteristic or just a sample statistic that goes with those categories. Okay, so that's what part of the homework will be all about, is determining, is it a population or is it a sample, and going from there. So here's the deal. We have to do our best to select our sample from the population, and this has to be done as randomly as possible. And in order to do that today, I'm going to illustrate one way that we can do it, which is by using a random digit table, which, as it implies down below, if you look at it, it's just a series of random numbers. And of course, there's computer programs that can do this for us. Our calculator can help us generate random digits. But I'm going to show you a way quantitatively right now, if you have a random digit table, of how we can select students at random. And there is a specifically defined process that we're going to use. If you look at number 3 on page 30, it says you must randomly select 2 students from your math class of 28 people. We will use the random digit table to select these students. And you can see that random digit table below. So let me write down the steps down here that we're going to take, and then we'll actually pick our students. Okay. So first of all, in our class of 28 students, we have to number them. So we're going to randomly assign numbers to all the students. And what we'll do is, since we have 28 of them, let's assign them to have a number somewhere from 1 to 28. Okay, so for things that are single digits, we're going to classify student 1 as being 1 in that case. All right, in step 2, we're going to now select 2-digit numbers from the random digit table. So that should be pretty easy. And by the way, it doesn't matter what row you start in. I'll pick a random row and we'll get started in a moment here. But we're going to select 2-digit numbers from the random digit table. And step 3 is talking about, well, what don't we want? What are we going to ignore? Well, anything in our 2 digits that's a 29 through 99, we don't have any students with those classifications. We also want to ignore if we get 0, 0. We didn't label one of our students as 0, 0. Could we have? Sure, I guess we could have done that. but then I would have stopped at 27 here. That would have been okay. And then we want to ignore any repeats. So if we're going across that row and I get student 15 to pop up twice in a row or something like that, we don't want to choose the same student twice. Okay. Now, when I say select 2-digit numbers from that random digit table, again, you could choose any row that you want to start in. So we might all wind up getting different answers in the end if we're using this random digit table. So for example, if I start with, let's just say, picking row 2, because I like the number 2, if I look at the first 2 digits, I would have student 80 to look at. But 80 is definitely not in our range of students. It's from 29 to 99, so I don't want student 80. And then the next student would be student 31, and well, there's no student 31. But then if I go from here, we have student 11, so that works. The next student would be student 12, and we only need, by the way, 2 students. So I think we found them. We would say that we need student 11 and student 12. These are the 2 students that are randomly picked from this table to help out with something in class. Okay. Now, again, if I were to start at a different row, what would I find? I guess I would have to keep going until I get something that works here. You know, if I start up in the top row, it's going to take a little while. 66, 72, 80, but 08 works, right? So we could have picked student 8 randomly. You know, student 40 is non-existent, but student 4 would be another option as well. So depending on what row you start with, you just want to indicate that somehow, whether by drawing an arrow, circling it, so that I can see which row you've decided to create this random selection here. But writing down these steps is a part of the process that you should include in terms of numbering the students. How are we doing that? Then saying that you're selecting 2-digit numbers from the table, and then finally writing which options we're going to ignore in the end. Okay, so that's something that we'll get used to as we do more practice. What we'll do is let's leave the rest of this for class next time we're together. So the rest of page 30 and then on to page 31 for our day 5 notes with representative samples. We'll leave that for class next time we're together. So a short, quick lesson for day 5 of Unit 18. If you have any questions, let me know, but have a great rest of your day.